A little bit of background about the NTTA for those of you who are not familiar with us. We are essentially the toll road association around the Dallas-Fort Worth Metroplex, which means we have a lot of people that like to drink. So back in 2009, we had a bunch of issues with wrong-way driving. Several fatalities happened in 1 year on our system, so as a result, we decided to form a task force. As our system is basically a high-speed system, it's a toll road. We do have frontage roads, continuous in some areas and non-continuous. So we're a little bit different than a city and a municipality, but we're not quite as big as TxDOT. So what we did was try to focus on things we could do. We are a smaller entity, so we jumped on some things pretty quick, which I'll cover today. So what we realized is that the first thing we were going to try to do is ban alcohol in the Dallas-Fort Worth Metroplex. The alcohol lobby was a little bit bigger than we thought, so we decided to see what else we could do. So we tried different enforcement methods. Once we realized the cost of fuel and the pavement damage after the first explosion, we realized that this was getting a little bit of complaints about the noise from the neighbors, so we decided to move on to more traditional methods. You'll hear a little bit about car spikes. Car spikes, I think we all know as engineers, just don't work on ramps. There's lots of studies that say don't put them on there. They cause damage to the right-way vehicles, plus at 60 miles an hour. Do you really want to take your chances? So we decided that we all have signs. We all have signs out there. What can we do different to the signs to catch somebody's attention? We tried to run this through traffic ops, and they said, no, I don't think that's in the MUTCD for an exit ramp. So we moved on. We did install LED enhanced lights back in 2010. We did them in 3 different locations. One of them is in a very dark area that has no continuous roadway lighting, and they were effective in that area. Another area has very well lit, very continuous lighting. It's very well lit up, not as effective. It's a very small sample size, but I do have to weigh the pros and the cons. I can tell you that in the 3rd location, nothing's working, and we'll get to that location in a little bit. So we decided also to see what we could do that was cheap. We immediately went out back in 2009 and put RPMs and tape on the signs. At night, it looks like that. Again, it's all to grab the attention of the person to try to tell them not to go the wrong way. Because as Melissa said, all of ours have been happening in the same time frame. Bars are closing, people are getting out there. And all the fatalities we had and all the accidents we had were a result of alcohol. So grabbing their attention before they get on there was our main goal. So as we started to look, lowered signs really caught the attention of us. Throughout the states, there were several studies that said lowered signs do this and lowered signs do that. So we said, that's great, that's awesome, let's lower a sign. The MUTCD says 3 feet. We said, okay, great. How did we come up with that 3 feet? Just being a little curious, we didn't just want to follow the flock. So we looked in the minutes of the National Committee, we looked through a lot of different stuff and a lot of different studies, and we really could not find where 3 feet was the magic number selected. We looked through Google, and if it's not on Google, it doesn't exist. So what we did was we realized to say, okay, if we want to lower signs, what are we trying to catch? We're trying to catch the drunk's attention. Well, what are they doing? They're driving with their headlights. Their headlights in Texas are 24 to 54 inches by state law. So at 3 feet, we're missing a foot of sign. Does that make a big difference? Yes. When we looked at it through TTI study, 78% brighter sign at 2 foot than 3 foot. So with 3 foot being, we don't know how it came up with, and 2 foot being brighter, we realized, okay, let's try to catch the attention of them as best we can. Drop it to 2 foot. Well, we looked and we said, okay, FHWA, we'd like to do this at 2 foot, and they said nothing's been crash tested. The argument of nothing's been crash tested at 3 foot at the time didn't hold any water and didn't matter. Those of you who've been through the request for experiment process. So you can see these pictures were actually taken on the Riverside campus of the signs we did crash test. After successful crash testing, we went and implemented it at 28 locations. And in the pictures you can see small cars grabbing the headlights, trucks grabbing the headlights. And that was the whole point, 78% brighter. Once we did install these lowered signs on our system, they've been in place for a number of years. We have seen a 56% reduction in wrong-way driving events at the areas where we've had lowered signs. We're currently in the process of requesting a jurisdictional approval to go put more signs out. We started really paying attention back in 2009. So now from 2009 to 2015, we have a lot of before data. We hope to get jurisdictional approval to be able to drop some of these signs in areas we know wrong-way events are happening, to really prove, is it the lowered sign or is it something else? So here's what they look like installed, and as I mentioned, a 56% reduction at ramps. We did different configurations. We did keep in mind site visibility. We did keep in mind anywhere where there was guardrail and sidewalks, so we did study the locations. We didn't just randomly put them out there. But what I want to talk about a little bit today is something that we realized we need to go out above and beyond our system. You'll see a lot of things today about LEDs and things like that. We realized that, you know what, if we can prevent them from getting near our system in the first place, we can stop them from getting on our system. So we started partnering. We've all kind of seen this. In this picture, this is this northern end of one of our systems, the Dallas North Tollway. The road going east and west is a state highway. Our frontage roads are what you see north and south. We've had a lot of folks that were turning up to this intersection and saying, hey, I can turn left here, but you can't. We mean for you to go to the next one. So back in 2010, we worked in partnership with TxDOT, and they said, absolutely, please, anything we can do to help. We started doing that. That little bitty arrow made a lot of difference. Now, as they approach the intersection, they see I've got to go straight. The next bank of arrows says turn left. Remember, we're dealing with people that are not in their right state of mind, or just a little confused. As you saw, this is out in the middle of nowhere. It's really dark, so you couldn't tell, hey, do I turn here or turn there at the end of the day? The arrow says keep going straight. Another area where we partnered with the city of Dallas. In this map, you can see 3 red lines and 3 yellow lines in the top left. The Dallas North Tollway, this is the southbound lanes of the Dallas North Tollway. In the middle, you can see American Airlines Center parking. That is where the Stars and the Mavericks play, and then just a few weeks ago, Garth Brooks did 7 concerts there. So what happens is those 3 lanes from the northbound or southbound Dallas North Tollway and 3 lanes from Harry Hines join together, and it looks like this. It's 6 lanes in one direction. Now imagine you've been boot scooting to Garth Brooks till 2 o'clock in the morning, and you've had a little bit to drink. You come out of the parking lot that's right off of this and think, I got to go north because that's where my GPS says to go. Well, the GPS was trying to tell you to go 1 block over to turn north. You just turned north because you heard the sweet voice say, turn left here. Unfortunately, you're going the wrong direction. So what we did in partnership with the city of Dallas was come through and miles down the road installed arrows, the correct direction to turn. For example, on the left you see the before condition. The little branches were blocking the one-way sign. There was nothing on the ground to say, hey, this is the direction you turn. So what we did was just put in reinforcing arrows. This is the correct direction to turn. Remember, they're focused down, they're focused a little bit on something else, and they're listening to the GPS saying turn left here. Anything we can do to grab their attention. Here's another one where, as you can see on the left, it's a little confusing. There's a right turn arrow that exists. So if that's a right turn only, then that must mean left and straight. Unfortunately, no. This is only straight through, so we added words. Same thing as we get close to that 6 lanes wide. We actually just put reinforcing correct direction arrows on the ground. And then we went through on all the signal heads, and on the back of the signal heads put wrong way. When we were out there at night, we realized that if you are standing there, because of this light, you can see the red, green, and yellow just through the back of the lenses. We thought if we could grab your attention by seeing the red, green, and yellow, and you look up and see a sign that says wrong way, at least what you'll do is get confused and maybe slow down and stop potentially. But what we were seeing is if I was going, I could see how you look up and you're waiting for the green light. Well, we put something up there to try to catch their attention before it turns green. Hopefully they're reading wrong way. Another thing we did is we approached intersections. We started looking at words on signs and arrows and things like that. Again, this is all just to keep them away from our system, where they're going the slowest, where they're supposed to be going 40. And as one police officer said out of San Antonio, they have the best, the most politest, bestest, correctest driving wrong way drivers you ever have. They're going 10 and 2, they're going 55 miles an hour just under the speed limit, going perfectly in their lane. So we're trying to catch them when they're slow. We also said, hey, you know what? If we've got a confusing intersection that's corrected, we need to correct it. So as in this picture, you can see the little black car in the middle, the right, where those 2 right turn arrows are, that is the on-ramp to our Dallas North Tollway. That's the southbound that's an exit ramp, I'm sorry, not an on-ramp. That's the problem. They're using it as an on-ramp. So as they would come off, here's a little bit better. If you're sitting at that left turn bay, and you're coming out of the city of Dallas and you've boot scooted to Garth Brooks, you come here and you see that and say, I don't want to turn here, I want to go that direction. So what we did was come back and work with the city of Dallas to actually close off that left turn lane. And install a different median opening. So at the end of the day, we closed it off. And again, this is partnering with the cities and partnering with other groups, getting off of our system, as you'll see in some of the other presenters, trying to prevent them from getting there in the first place is what we kind of looked at. So as a toll road agency, we also have a little bit of technology in the ground that others don't have. We do collect money. And as a result, we have loops in the ground. Much like traffic signal loops, we count the axles, charge you by the axle. So as the car goes by, thank you, we collect your money, you move on the road. If you go the wrong direction in those loops, we do have an alert that goes to our 24/7 traffic management center, which also dispatches state troopers. We do have troopers directly working under contract for us on our system, so we actually dispatch them from our traffic management center. We're a secondary 911 center. We receive the calls about the wrong way drivers. We get the alerts and have direct contact with the police. So what they will do is catch the loop. It tells them where it's at. It allows them to pull up the camera. They dispatch the state troopers. We also contact the local PDs and our roadside assistance group just to keep an eye out to try to confirm for these folks. And when it works, it works. In 2014, we did catch 14 people using our loop detection. So far to date, we've got 12. So if you do the math, we're a little bit more on track to catch a little bit more this year. I contributed to Garth Brooks. We are also working on a little bit more technology. One thing we're working on is because of our ITS and because of our cameras, we are working on a content analysis. If we can use the cameras to pick them up going the wrong direction, you don't need the loops. We can provide the technology to other folks. So we've partnered with some other folks and said, hey, what can we do? Well, the idea is the correct cars, the maroon cars are going the correct direction, the burnt orange car goes the wrong direction. An alert is sent to our traffic management center, which then types in that, hey, we found a wrong way driver. It's sent out similar to an Amber Alert. We're trying to work on a geofenced app that will basically send it out as an Amber Alert. If you are on that system and going that direction, something's coming up, be prepared. So we're trying to get it out to the right way drivers to say, hey, look out, whatever we can do. And if you're in the area, stand back. And hopefully, the wrong way driver that gets it in their car too goes, wow, I wonder who that is, slows down and stops. So the idea is that, as you can see in this video, maybe, there we go, we have somebody coming the incorrect direction. And the car on the right is even flashing their headlights. So immediately, what does the wrong way driver do? As they go out of frame, you'll see that we are seeing an uptick of, anybody can catch what he does different from the last one if I can put the video. Whoop. There we go. I was impatient. Anybody can tell me what this wrong way driver starts to do? Yeah, they turn their hazards on. There's crazy people out there. I don't want them hitting me. These are a couple of cameras that are on that south end there, like I mentioned. As you can see by the camera stamp, it's 3 a.m. in the morning, so no surprise. This driver actually went another little bit and U-turned. And we've actually seen about 40% of our drivers on our system U-turn and correct themselves. People say, wow, that's great. We are catching it as there's 40% of them that we can still try to catch that are somewhat cognitive, able to pick up on some cues that I'm going the wrong direction, that we're trying to work on before they get onto our system. Whether it's either continuing to partner with other agencies or implementing additional ITS stuff. So we see that as 40% that we can still cut. We just haven't found out how yet. But we will continue to partner with other agencies and other entities to work on that. So with that, thank you very much.